Hello, my name is Ronald Zung with number matrix F25A2012. I will briefly explain the synthesis strategy for converting a terminal alkyne into an aldehyde. First, the terminal alkyne is deprotonated using sodium amide in liquid ammonia to form an acetylide ion, which is a strong nucleophile. Next, the acetylide ion undergoes an SN2 alkylation reaction with 4-5-bromide to extend the carbon chain of the alkyne. Finally, the terminal alkyne undergoes hydroboration oxidation using CY2BH followed by hydrogen peroxide in basic condition. The reaction occurs in an anti-monochemical manner and produces an aldehyde as the final product. So that's only for my part. Thank you.
To do this, we carry out a Friedel-Crafts alkylation by reacting benzene with methyl chloride CH3Cl in the presence of aluminium chloride AlCl3 as a catalyst. This reaction attaches a methyl group to the benzene ring, converting benzene into toluene. Once we have toluene, we need to make the methyl group more reactive so it can be changed in later steps. This is done by reacting toluene with bromine Br2 in the presence of heat. Under this condition, bromine reacts with the side chain rather than the benzene ring, forming benzyl bromide. This bromine atom acts as a useful handle that allows further chemical reaction to occur. Next, benzyl bromide is react with aqueous sodium hydroxide NaOH under heat. In this substitution reaction, the bromine atom is replaced by a hydroxyl group. As a result, benzyl alcohol is formed. This alcohol is an important intermediate for the final steps. Finally, benzyl alcohol is reacted with acetic chloride CH3COCl in the presence of pyridine. Pyridine acts as a base and neutralizes the hydrochloric acid HCl produced during the reaction. This step forms an ester linkage, giving the final product, which is benzyl acetate.
Benzene reacts with Br2 and FeBr to produce bromobenzene A. Bromobenzene A reacts with Mg to produce the Grignard reagent, phenylmagnesium bromide B. Phenylmagnesium bromide B reacts with formaldehyde H2CO, followed by H2O to produce benzyl alcohol C. Benzyl alcohol C reacts with PCC to produce benzaldehyde D. Benzaldehyde D reacts with ethylene glycol under acidic conditions to produce cyclic acetylase E.
Propose an efficient synthesis for the following transformation. The key strategy is make an alkene, cleave it open, then do reductive elimination twice. First, we introduce a leaving group using Br2 and light. This starts radical bromination at the most stable position. Then we add sodium hydroxide, which performs an E2 elimination, giving a methyl substitute cyclohexene. Next comes stirring opening step, ozonolysis. We treat the alkene with O3, TMS, which cleaves the double bond. Since the alkene is inside a ring, ozonolysis breaks the ring open, forming a linear dicarbonyl compound with clear carbonyl groups on both ends. Finally, we install the amines using reductive elimination. We react the dicarbonyl with dimethylamine under acid to form iminium ions and then reduce them with NaBH3n. Because this happens at both ends, we get the final product, a chain with two tertiary dimethylamine groups, exactly as shown.